Good morning, Cappuccino. Here is your warm-up for today. It is a bit of a doozy, and my dogs are already complaining about it. So think hard on these. These are tricky. This one's not so bad. This one I thought was pretty tricky. Although you might be able to check your way to the answer on this one, but I want you to try and do it using algebra. And I would love to see if somebody can figure out how to do it more efficiently than me. I took the long way to getting the answer. So anyway, good luck with those. Let's go over the warm-up from yesterday. So a review of logarithms. Logarithms are extremely important in a lot of different applications. I had a student who went off to nursing school a couple of years ago, and she said one of the most important things she learned in IB math was about logarithms. So here we go. Let's look at some logarithms. Athena. Let's see if my dog will be quiet. Okay, so if I have log base b of b to the fourth, one thing we should remember from our work with logarithms is if we have an exponent, we can move it to the front. So this is going to come here. So this is the same as 4 times log base b of b. And by the way, you can always get out your formula packet. Remember, there are lots of formulas in your formula packet, and I don't know what I did with my formula packet. I would show it to you right now, but I can't find it. So hopefully you can find yours. Okay, so now this part, I think I can simplify this. Okay, this dog barking is going to make me crazy. Athena, shh, quiet. I might have to kick her outside. All right, so I'm going to call this x. Log base b of b, I'm going to call that x. So I can call this whole expression, I'm doing a little substitution, kind of like U substitution. So I could call this 4 times x. So if this is x, I want to try and simplify this by rewriting it in exponential form. So exponential form, remember the little letter here is the base. So that's my base. The x is the exponent, and the value is the b. So b to the x equals b. So what do I have to raise b to in order to get it to equal b? Oh, x is just equal to 1. Okay, so that's something that hopefully you'll get used to. If you see log base of a number and the value is the same number, that means this just equals 1. So my answer is 4 times 1, which is just 4. Okay, so the answer to that first one, that just simplifies to 4. Okay, this part right here simplifies to 1, and the exponent, of course, moves in front. So that's the super fast way of doing it. Okay, next one, if you just look in your formula packet, we have formulas for this. If you're adding logarithms with the same base, notice these are both natural logarithms, so they have a base e. If you're adding logarithms with the same base, that means you just can multiply the values. So this is just the same as natural log of ab. And now you may ask yourself, can I simplify that? So let's try it the way that I did here. Let's set it equal to x and see if I change it to exponential form, does that get me anywhere? Okay, so if I rewrite it like this and say, okay, does that equal something? Can I simplify that? Remember, natural log, the base is e. So e to the x equals ab. E to the x equals ab. Can I solve for x? No. So that doesn't help me because I cannot solve for x. Okay, so if you rewrite it in exponential form and then you can't solve for x, don't worry about it. Then that's your final answer. Okay, you can't make it any simpler. So this one, when I did change it to exponential form, see how I was able to solve for the x? That meant I was able to simplify it further. Okay, so that's a little tip. Try changing it to exponential form to see if you can simplify it more. If you can't, then backtrack and just leave it as a logarithm. Okay. So next one, looks like we're going to pull the same trick. I got this 3 here. I can bring it down front. 3 log square root of b times b. Give that a try. Okay, so just like I did on the first one, I'm wondering, can I simplify this? So I'm going to change this to 3x, where x is equal to log square root of b to the b. Or I actually kind of like putting the equals x on this side. I don't know why, but I like to, so I'm going to put it on this side. All right, so let's see what happens if I rewrite this in exponential form, because right now this kind of looks like that, but not exactly. Shh, Athena, quiet. So b, square root of b to the power of x equals b. So I'm just rewriting it in exponential form. So can I simplify this? Square root. I can rewrite a square root as a fractional exponent. Okay, that's super important. You got to know how to do that. That is a basic skill. And keep my to the x. Oh, this is looking promising because they have the same base. So now I can simplify my exponents, laws of exponents. I multiply those together. So I get x over 2 equals b, oops, broke my lid, b to the, what's the invisible exponent? 1. So if the bases are the same, we can set the exponents equal to each other. Aha! So now I can solve for x, multiply both sides by 2. I get x is equal to 2. But don't leave it like that, because remember we did some substitution back up here. So let's take that back up to the top. So substitute back in. I simplified this expression right here. That just equals 2. So the whole thing is equals 6. And you can actually check this on your calculator. I did. I picked some numbers for b, and I put into my calculator 3 times log, and I did the change of base function on my calculator. And I did the square root of some number and that number, and voila, it was 6. And it doesn't even matter what number you choose to represent b. Just remember the b here is the same as the b there. Okay, so that was letter C, pretty tricky. Letter D, oh, I'm running out of room. Okay, if I look at this, I notice something really weird going on. I notice that I've got b here and I've got a b squared over here. What the heck? So I want to know, how can I rewrite these? So I'm going to change this to x. Well, I'm going to first of all bring my 2 up down. Okay, so I'm going to have 2, and then I'm going to call log base b of b. I'm going to call that x. And then this one, I'm going to see if I can simplify that. I'm going to call that y. Okay, so my x is equal to log base b of b, and my y is equal to log base b squared of b. And let's see if we can simplify that. Oh, hey, haven't we seen this before? That's just equal to 1. X is just equal to 1. Hey, so I'm off and running. So the first part of this is just 2 times 1, which is just 2. So right away, I know this simplifies to just 2. Okay, I bet this simplifies to something really nice and easy. All right, so let's go ahead and see if I can solve for y. My neighbors are trying to sell their house, and so they have like workers over there all the time, and their dogs are going crazy. All right, let's rewrite this. B squared to the y is equal to b. Let's see, b squared is my base, raised to the exponent of y is equal to b. Okay, sorry, I'm running out of room here. So multiply my exponents together, I get b to the 2y is equal to b. And that's b to the first, that's the invisible exponent. Look, bases are the same. I can set these equal to each other. So 2y is equal to 1. Divide both sides by 2. I get y is equal to 1/2. So I can go back to this. My y is just equal to 1/2. Okay, log base b squared of b is just equal to 1/2. So final answer is 1.5, or 3/2. Yay! All right. Okay, the next two are actually pretty easy, pretty straightforward. I can just change it to exponential form. I think I have room to just do it on here, so let's do it. So I can change this to exponential form. 2 to the 5th is equal to 7x plus 4. 2 to the 5th, what is that? 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. 32 is equal to 7x plus 4, and then you can solve it from there. And you get x equals 4. Okay, you can do that. X equals 4. All right, the next one is also fairly straightforward because the logs have the same base. So since they have the same base and I'm subtracting, I can go ahead and divide these. So log base 3 of x divided by x minus 6 is equal to 1. And then I can change it to exponential form. 3 to the first. 3 to the first equals x over x minus 6. 3 to the first is just 3. So to solve this, I need to get this x minus 6 out of the denominator. So I'm going to multiply both sides by x minus 6. distribute that, I'm going to get 3x minus 6 times 3 is 18 is equal to, these cancel out, is equal to x. Okay, I'm going to minus, let's see, I want to leave my 18 here, so let's minus 3x from both sides. Minus 3x minus 3x. So I get negative 18 is equal to negative 2x. Divide both sides by negative 2, and I get, oh, there's a little note to myself, and divide by negative 2, and I get x is equal to 9, and there it is. Okay, so good luck on today's warm-up. Think about what I did with these problems right here to help you on this one. This one is pretty straight. It's a little bit more complicated than this one. Okay, so you got to think of my tip for the day is what can you do with that? That's kind of a problem right there. So what can you do with that? All right. There is not going to be any new notes today. The assignment today is going to be some word problems using the trapezoidal rule. They're going to be a little bit trickier than yesterday. Not terribly trickier, but a little bit trickier. Yesterday's were pretty straightforward. They're in math space. So there is going to be, how many problems? There's going to be 1, 2, 3, 4, 5 problems, and I'm going to throw on a couple extra for people who are planning on being a STEM major next year for college or taking HL next year. Okay, so the minimum requirement, there are 5 problems for the minimum requirement, and then there will be a few extra for people who want to push themselves. All right, have a great day. Oh, by the way, there will be no new lesson tomorrow because I've been told to chill on how much work I give. All right, so no new lesson tomorrow. This is it for the week. And tomorrow we will have a Zoom meeting for you to ask questions. Okay, and that's at 10:20. And if nobody shows up by 11, I'm going to turn off at 11. So make sure if you want to see me that you show up before 11. Okay, because if I'm alone at 11 o'clock, I'm going to be ending the meeting. All right, see you tomorrow. Bye-bye.